Let's have a look at the quadratic formula then. So the quadratic formula can solve any quadratic equation, but naturally for the more straightforward quadratics that we looked at in the other video, if the numbers are easier inside this quadratic, then it is quicker to factorize, as we've seen how to do in the other video. Okay, but sometimes these numbers can be very difficult, and sometimes they won't even factorize. Okay, sometimes they'll be decimals, as we'll have a look at an example later, and again that makes it very difficult to factorize. Now the quadratic formula is shown here. So we've got x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now this a, b and c relate to the a, b's and c's inside the quadratic equation. Okay, so it's very important you've got this in quadratic form first. So for example, if you had a number on the right hand side here, say we had a 4 on the right hand side here, you'd have to make sure that you take it to the left hand side to put it into quadratic form first. Okay, so for example, if you had x squared plus 3x is equals to 4, a big mistake people make here is they say that a is the number in front of this x squared, so 1 in this case, b is the 3 in front of this x, and c is this 4 on the right hand side. Okay, that's wrong. Well, this part is correct here, but this part here is wrong on the right hand side of the equation. It's very important that we get it into quadratic form first. Okay, so c is equals to minus 4, and naturally that would affect how the calculation works out. Now this part inside the quadratic equation here is what we call the discriminant. Okay, so the square root b squared minus 4ac, this is what we call the discriminant. Okay, and what this does is it tells us the nature of the roots to the equation. Okay, so what I mean by the nature of the roots is, are they repeated roots? Is there just one solution? Or are there no real roots? Okay, so if this is a number above 0, okay, so if this is a number above 0, then this means that we have two roots, okay, two distinct roots. Right, so what this would mean in terms of a graph, if I just quickly draw a little graph at the bottom here, this means that we have two roots like this. Okay, if this is equals to 0, okay, so if this number here under the square root is equals to 0, then it means we have one root. Okay, or a repeated root. And what this means is that on a graph, it would touch the x-axis at one point here. Okay, so you'd have one root. If this is a negative under the square root, now of course remember that we can't take square roots of negative numbers, so if this is below 0, then what we have is a set of complex roots. Okay, complex roots. So in other words, there are no real roots to this equation. And what we need to do to find the roots to that equation then is look into complex numbers. Okay, so if we were to have that on a set of axes again, the function could look something like that. Okay, so it wouldn't cross the x-axis. Okay, so we'll look at this further when we go into the complex numbers lecture. Let's have a look then at a solution to a quadratic equation using the quadratic formula. So we've got a quadratic here, 8x squared plus 15x plus 7. Now, when you're using the quadratic formula, it doesn't necessarily mean that it doesn't factorize, of course. But what you've got to weigh up is looking at this quadratic, you've got to think, would it be quicker for me to use the quadratic formula, or would it waste my time if I went through the rigmarole of trial and error trying to factorize this? Okay, now this doesn't look like a nice one to factorize, but we'll see at the end that it does actually factorize. Okay, but going through the trial and error would take longer, I would say, than doing this by the formula. Okay, so the quadratic formula then, remember, we've got A, B, and C. And if you remember, the formula is x is equals to minus b plus or minus the square root of b squared minus 4ac over 2a. So let's substitute these numbers in then. And once you've substituted the numbers in, that's pretty much all the work done. There's no trial and error or any kind of guesswork with this. It's just a case of working out what these numbers equal to. So you've got x is equals to minus 15. Okay, so there's a minus b there, of course, so b is 15. We've got minus 15 plus or minus the square root of 15 squared minus 4 times 8 times 7. I'd always put these in brackets, especially if you've got any negative numbers in the quadratic. It does make it easier to look at, and especially if any of these are negative. I see some mistakes sometimes where people then start doing, for example, minus 4, minus 8, minus 7, rather than multiplying them together. And this is all over 2 times 8. Okay, so we've got the numbers in then. Let's work out what these are. So we've got minus 15 plus or minus. 15 squared is 225. Minus 4 times 8 times 7 is 224 over 16. So we end up with some nice numbers here. Square root of 1, yeah, 225 minus 224 is 1 over 16. And of course the square root of 1 is equals to 1. Okay, so this is what we're dealing with now. Now remember, we've got two roots to a quadratic equation. We might end up with the same number, okay, but we generally have two roots to a quadratic equation. So where do we get the two roots then from this? Well, this is where the plus and minus part comes into play. Okay, so we've got x is equals to minus 15 plus or minus 1 over 16. If I just write that line down again. Now the way we get the two roots from this is we now split this up into two. Okay, we write this down with the positive 1. Okay, so we use the plus. And we write it down with the negative. Okay, so minus 1 over 16. And this is now where we get the two roots from. So let's work this out then. So we've got x is equals to minus 14 over 16. Which, if we cancel it down a little bit, will give us minus 7 over 8. And on the right then, we've got minus 16 over 16, which gives us x is equals to minus 1. Okay, so these are the two roots to the equation. Now, what I usually say is that if we get nice-ish numbers here for the roots, it usually means that this would have factorized. Okay, so I know that this isn't a nice number, but we've got a nice whole number here. So looking at this, I would think, did that actually factorize? And it did factorize. So the factorized version of this would be this. Okay, but you've got to weigh up, as I said earlier, whether it would take you longer to do some trial and error to try and factorize this, or just stick it in a formula and get the answers. Okay, once you get used to doing this quadratic formula, you can get through it quite quickly. So another look at then a quadratic that I would use the quadratic formula for. So here we've got decimals inside this quadratic. Now, I'm not saying this wouldn't factorize if you've got decimals in here, but you would be a long time trying to look for numbers that multiply to give -3 and add to give 0.5. It would be very difficult to do so. Okay, so before even attempting to factorize that, I will go straight into using the quadratic formula. Okay, so we've got A is 0.8, B is 0.5, and C is -3. So it doesn't matter if these are fractions, decimals, or negatives, it'll still work in the quadratic formula. So we've got x is equals to minus 0.5, so minus b, yeah, plus or minus the square root of 0.5 squared minus 4 times 0.8 times -3. Okay, so remember, c there is -3. This is why it's important to put them in brackets. It does make it a bit clearer. And that's all over 2 times 0.8. So let's work these out then. Got to be careful because they're decimals. So we got minus 0.5 plus or minus 0.5 squared is 0.25. And then we've got minus 4 times 0.8 times -3. So we're going to have a negative times a negative there, which will mean that we end up with a positive. And the number we get is 9.6. Okay, so do that in a calculator. And 2 times 0.8 is 1.6. Let's work out this part that's under the square root then. So if we add 0.25 to 9.6, we get 9.86 over 1.6. And if we take the square root of 9.86, we get 3.1401 over 1.6. Up to you if you want to do that to less decimal places, but in this case I've done it to 4. Okay, so remember now we want to split this up into 2 to get our 2 roots. So what have we got? X is equals to minus 0.5 plus 3.1401 over 1.6. So if we do that one first, we get x is equals to 1.65. So that's the first root. And we've also got x is equals to minus 0.5 minus 3.1401 over 1.6, which will give us x is equals to minus 2.28. Okay, so because of the decimals in the original quadratic, it does make it a bit easier, well, much easier if we do it through the quadratic formula. Let's have a look at an equation then that isn't in quadratic form as it stands there, but we'll see that we end up having to solve a quadratic equation. So the issue with this equation, of course, is that we've got this x on the bottom here. Okay, ideally when we are looking at equations, we want x's all on the top. So how could we get rid of this x underneath the 3 here? Well, remember we can multiply an equation by anything as long as we multiply every term by whatever we're multiplying by. So to get rid of this x on the bottom here, I need to multiply this term by x. Okay, because if I multiply this by x, I'll have 3x over x, and of course the x's will cancel. But of course I can't just multiply this by x, I've got to multiply the whole equation by x. Okay, so if we multiply the equation by x, what do we end up with? So x times 2x is 2x squared. X times 3 over x is 3x over x. So if I just write this down for now, so we can see how they cancel. And x times 6 is 6x. Can we see now that these x's will cancel, and we are left with 2x squared is equals to 3 plus 6x. So we've got an x squared in here now, which means that we're going to have to solve a quadratic. But of course, before we solve a quadratic, we need to put it into quadratic form. Okay, so let's get it all onto one side. Doesn't really matter which side you get it onto. Generally though, it's nice if you've got a positive in front of that x squared, because we could potentially factorize this. Okay, so let's take it all onto the left hand side. So we've got 2x squared minus 6x minus 3 is equals to 0. Okay, now we need to solve this quadratic. Okay, so we'll use the formula for it. A is 2, B is minus 6, and C is minus 3. Let's put it into the formula then. So we've got A, B, and C. So x is equals to minus b. Always be careful when this b is a negative, okay? Because the formula starts off with minus b, means you're going to have minus a minus, okay? So minus 6 plus or minus the square root of b squared, so that's minus 6 squared, minus 4 times a times c, so a is 2, c is minus 3, and that's all over 2a. Okay, so 2 times 2. Let's work these numbers out then. So minus 6, of course, is just a positive 6, plus or minus the square root of minus 6 squared is 36. And always be careful if you're putting that in a calculator, remember to put brackets around it. Okay, quite often if you put minus 6 squared in a calculator like this, it'll do 6 squared, which is 36, and then put a minus in front of it. Okay, so always be careful of that. Use brackets in your calculator as well. So we got 36, and then minus 4 times 2 times minus 3 will give us a plus 24, and that's all over 4. And let's add these up inside the square root. So we've got root 60 over 4, and root 60 is 7.75. Now if we break these up into 2, we've got 6 plus 7.75 and over 4, and 6 minus 7.75 over 4. So we've got 6 plus 7.75 over 4 and 6 minus 7.75 over 4. And we get our two roots then as 3.44 and minus 0.44. Okay, so these are the two roots to that equation. All right, so always remember then that whenever you see an equation and you've got an x squared in there, you always need to get it into quadratic form before you can solve it, either by factorizing or by using the formula if the numbers look a bit too difficult. Another example here then of an equation that does end up being a quadratic, but it doesn't really look like one initially. Okay, so we've got brackets on both sides of these. If you look at the linear equations video, we'll see that we did some of these, but the x squareds ended up cancelling. Okay, now we'll see that in this case they don't. So first thing we want to do is multiply these brackets out so we can have separate terms, which makes it easier to manipulate the equation. So let's multiply this out first. So we've got 5x squared plus 10x plus 3x plus 6. And on the right hand side, we've got x squared minus 3x minus 4x plus 12. Okay, so I've had to squeeze that in a little bit. And of course, when we group some terms together, then we end up with 5x squared plus 13x plus 6 is equals to x squared minus 7x plus 12. Okay, so we've got two quadratics now, one on each side. What we want to do is get this into quadratic form. So remember what we do, take it all onto one side. So we've got 5x squared plus 13x plus 6 minus x squared plus 7x minus 12 is equals to 0. And now we want to group terms together, so we get this looking like a quadratic. So 5x squared minus x squared will give us 4x squared. 13x plus 7x will give us 20x. And 6 here minus 12 will give us minus 6 equals to 0. Okay, so this is now the quadratic that we want to solve by the quadratic equation. So you could divide this by 2 to make the numbers a little bit easier, but I'm going to just put them into the quadratic formula straight away. So let's put this into the formula then. We've got a, b and c. So a is 4, b is 20, c is minus 6. So in the formula then we've got x is equals to minus 20 plus or minus the square root of 20 squared minus 4 times a, which is 4, times c, which is minus 6. And that's all over 2 times 4. And if we work these numbers out then, we've got 20 squared is 400. Minus 4 times 4 times minus 6. So again, you've got 2 negatives, which is going to give you a positive 96 all over 8. And then we've got minus 20 plus or minus, that'll be root 496 over 8. Which will give us x is equals to minus 20 plus or minus square root of 496 is 22.2711 over 8. If we split this up then, what do we have? Minus 20 plus or minus 22.2711 over 8. Split this up into 2. So the first root then will give us 0.28. And the second root will give us minus 5.28. Okay.